Good afternoon, everyone. We'll be starting the webinar shortly. Good afternoon, everyone, and welcome. My name is Kostas Katsaros, and I'm Head of Technology for Future Networks and 5G at Zeta Catapult, also participating in UKTIN and running this webinar. The webinar organized by UK Telecom Innovation Network, UKTIN, is focusing on uncovering the horizon opportunities with the UK. We'll hear today from our European partners what is the actual opportunity or most immediate opportunity for collaboration in European research around telecoms and future networks, around the smart networks and services, the SNS joint undertaking. Also, you'll hear from our national contact point on how you can get help from the other national contact points on finding opportunities on horizon projects, and then listen from industry and academia from UK on what are the opportunities, what are our capabilities and strengths, and some interesting pitches from industry and academia on their respective capabilities so that you can potentially find your next partner for a consortium. Now, let me introduce Gemma Callendier from Department of Science and Innovation and Technology with a view from this seat. Gemma?
Thanks so much, Kostas. Great. Hi, everybody. My name is Gemma Calendar. I'm the international lead in the Advanced Connectivity Technologies team, formerly Future Telecoms. We have just recently changed our name here at the Department for Science, Innovation and Technology. And thanks so much for UKTIN for organising this event and promoting UK access to Horizon Europe. We at DCIT are really enthused about our Horizon Europe Association and the benefits of being part of such a totemic programme. So it's great to see your interest today and attendance, and also thanks so much to the panellists for a really exciting array of talks. So I just thought I'd spend a few moments discussing and why the UK government invests in telecoms innovation and thinks it's really important, and then move on to Horizon Europe and our involvement there. So broadly, we spend so much time thinking about telecoms innovation here in the UK for three reasons. Firstly, we are keen that high quality digital infrastructure is rolled out across the whole of the UK as it's foundational for the modern economy and a driver of productivity. Secondly, it's a crucial part of our social fabric. Our Minister, Sir Chris Bryant, has underlined the importance that this government places on digital inclusion, and that we cannot realise the full potential of our communities if there are people who are left out without connectivity. And linked to this is also the underlying role that telecoms technologies play in delivering better public services and improving people's lives. And lastly, it's a critical part of our national infrastructure and is crucial for collective security and resilience. So some of this can be achieved with the technologies we have today, but a lot of it will rely on the technologies that haven't even been invented yet to connect everyone in society wherever they are and to unlock use cases we haven't even conceived of. So that's why the UK government sees such value in telecoms innovation and companies and academics here in the UK working with our European partners to do that, because these problems and these challenges also are not unique to the UK. We know that our European partners see things in the same way and are equally keen to leverage the technologies to improve public services like enabling emergency services, smart cities, future transport networks, and to help us collectively meet our net zero goals and provide better health and social care. Horizon Europe will give us the opportunity to tackle these challenges and seize the opportunities together alongside our European counterparts. We have made several significant investments in future telecoms research and development in the UK, which Dimitri and Kostas will talk to in more detail. And we also have invested in lots of different support elements for accessing Horizon Europe, which again, Craig will talk to in more detail, which is fantastic. Like our European partners, this government is focused not only on ensuring the networks are secure and sustainable, but also recognising that digital infrastructure will play a pivotal part of delivering the AI industrial revolution, which was definitely a key theme at EUCNC, which a couple of you might have gone to a couple of weeks ago, and noted in the director's speech there as well. So we're really aligned on the importance of telecoms to that stream as well. And then just looking forward, I think other people might reflect on this, but 2024 was the UK's first year of participation following reassociation to the programme, and it's really encouraging to see such high levels of interest. And I want to acknowledge the UK organisations that were already engaged in the first Horizon Europe calls, and for which we were eligible. I think the UK ranked about 4th in terms of overall applications to SNSJU, which is really exciting, and it had a sort of average success rate among associated countries, which was great. And the result was that the UK was represented in several successful projects such as 6G Leader, Multi-X, and Sustain 6G. Really exciting, but we're looking forward to seeing an increase in UK participation and success over the next calls. That's our hope. So for 2025, we're moving on from just re-establishing those links to even more successful bids and partnerships. I hope today this event helps demystify and answer any questions you might have on Horizon Europe or about UK participation in Horizon Europe and the UK offer. It really is one of the most important funding streams for international R&D collaboration that the UK contribute to, and we're really excited to reap the benefits alongside our European partners. So that's sort of it for me. I'm very happy to answer any questions at the end.
Thank you very much, Gemma. And we now move to Dr. Alexandros Kaloxilos, Executive Director from 6G SNS Industry Association, to present on the Horizon opportunity from the SNS, the Smart Network and Services. Alex?
Hi, Costa. I hope that you can hear me and see me. Okay, perfect. Then, first of all, many thanks for the invitation, for being here today with you. My name is Alex Kaloxilos. I'm the Executive Director of the 6G Smart Networks and Services Industry Association, or 6G IA. The 6G Industry Association is the private side in the Smart Networks and Services joint undertaking. This is the second time that I'm presenting at a UKTIN event. I have also been invited in December. And for those of you that were present in December, you most likely have seen already that since then there have not been any real surprises from the things that I did present some months ago. I would like to say that the information about the SNS activities the R&I work program for 2025, as we call it, had been presented in an information day some days ago. And you can find all the related information, the videos from the presentation, the slides, etc., in the website of the Smart Networks and Services Joint Undertaking, so the SMS office. There is a brokerage event where you can also subscribe and provide your expertise or your ideas for possible calls. And already there has been a frequently asked question webpage, which I strongly encourage you to visit and see several answers to questions that the SNS office is receiving from DigiConnect and us, the Six Industry Association, we are receiving from various proponents. And just as a heads up, this frequently asked question is going to be further updated even during the current week. So please stay tuned because there are going to be some additional informations. The good news is that we have all the calls open now, stream B, C, and D, with a deadline the 18th of September. As Gemma said, it's a really good thing that we have the UK back on board, having a close collaboration since 2024, and it's a great opportunity for both sides, the UK and the European countries, to work together and achieve excellent results for Europe. So we look forward to further work with you. Now, if I could try simply to summarize what is on the table, very briefly, we have in stream B a strand, essentially, this is what we call it, the subsection of topics, which is related to disruptive technologies. So there is budget for roughly 5 topics of 3 million euros each for further advances on architectural topics, including deep learning, real-time serverless computing, cognitive agents, etc. So all this information is going to be there, so I'm not going to repeat it. It's on the documents and in the call. Simply to say that the important thing here is the following. The plan is not to invest again in technologies that we are well aware of. The thing is to touch upon cases and technologies where they could be promising, but we are at the very first stages of what we expect from this. So the TRL is going to be really low. The same thing applies for the strand about advanced IoT and device technologies. Again, we are talking about small projects looking future solutions for low TRL for IoT devices. And then we have the normal structure that we have been following during the past year, which is one strand for wireless communication. There is a significant budget of 21 million euros. So roughly you could envision something like 3 projects of 7 million euros each for all the things that are related to the 6G RAN, from the physical layer, massive MIMO, spectrum sharing, all the topics that we have in the call. And then we have, in terms of infrastructure, one topic for the integration of non-terrestrial networks with the terrestrial networks, and another topic which is about optical communication, including topics for optical access, backhaul, etc. These two, the NTN and the optical, they have a budget of 8 million euros, and we envision to have one project per topic, one for the NTN and one for the optical communication. For reliable service provision and security, there are 2 topics. The first one is called security services, one topic of 8 million euros, and another one about the reliable service operation. Again, one project of 8 million euros. What we further have is a topic where we are using this to find also some opportunities for further cooperation with the CHIPS JU. And the topic is about the front-end module with the targeting solutions for the frequencies of the FR3 band. Of course, people can also investigate at the same time potential integration with FR1 or FR2. But I have to say that the main focus will be the FR3 because, as you know, these days, and for the past couple of years, the FR3 is considered to be the golden band for the teleco industry. And this is the one on the FEM. It's one project of 12 million euros. And then we go to Stream C, where we have one project about the establishment of Telco Cloud, where open source solutions will have a key role to play. And of course, in case you are fully aware of the rest of the things that are happening in Europe, and I'm referring to the IPCIS project that is already active, working on Telco Cloud, and the call that is open in Cluster 4 about Telco Cloud solutions, you may think that there is a significant overlap, but this is not the case. What we are doing in the SNSJU is mainly on lower TRL solutions, targeting features of 6G networks, like deterministic networking, JCAS. So all these features that do not exist in 5G and 5G advanced solutions. And the idea is that the solutions that are going to be developed in this project will be also somehow ported to the higher TRL solutions under Cluster 4, where, to my understanding, DG Connect and DC, they are targeting solutions closer to operational networks. Finally, we have the calls for the verticals, so targeting, it's again significant budget, 24 million euros for projects of 6 million euros each. Where I would like to draw your attention is on the following. In the SNSJ, you have covered too many already verticals. So in terms of coverage, we are doing super well. But the target now would be to focus in one vertical per project, maximum two if there are any commonalities between the two verticals, but maximum in one vertical, simply trying to focus on engaging key stakeholders so that the result of the project will be an excellent example to sell what we are doing for 6G and why 6G can create monetize opportunities for the people that are going to be involved. So we would like to have some clear, as we already have with some of the existing projects in the SNS, but we have to be as clear as possible what is the opportunities from for the verticals to participate in 6G. So I think that I have used my time and I stop here. I'm at your disposal either today through the Q&A session, or do not hesitate to reach out to me if you have any questions, and I can be of help to you.
Thank you very much. Thank you very much, Alex, for this summary. As you mentioned, there was the briefing event and the info day on the 23rd of May, and there is a recording with the detailed analysis and the opportunity, so people can refer there. But for everyone, we have the Q&A session at the end. If you have any question, either for Alex or Gemma or the next speakers, please use the Q&A box and send your question, and we'll address at the end. Now we move to Craig Sharp, our national contact point for Horizon Europe in the UK. So Craig, the floor is yours.
Okay, thank you for that. Okay, I'm one of the UK's national contact points, and specifically I cover digital, and within that is the callers round about 6G. I'll cover a broad overview of Horizon Europe in relation to that, also touch on some related areas as well. Next slide, please. Thanks. Quick slide on national contact points, in case you haven't come across this before. The role is mandated by the European Commission, so it's a standard role and structure across the EU and associated countries and beyond. There's a small link on the right-hand side of the slide that'll take you to contact details of all the UK national contact points. Basically, we're here to provide advice, answer questions, try and help you figure out if your idea fits the topic, where it might fit, and if it doesn't, we'll let you know, and we'll also let you know what's coming down the tracks as well. We're publicly funded, we don't write bids, it's a confidential service. Next slide, please. Thanks. High-level overview in Horizon Europe itself. It's 7-year program, 21 through 27, with quite a sizable budget that doesn't include the UK's contribution. The funding for the 6G calls comes out in the Pillar 2 area in the middle under the Digital Industry and Space cluster. The cluster basically is a thematic funding area that funds a number of calls inside it throughout the 7-year period. As I say, it's collaborative R&D and it's obviously international. Next slide, please. Okay, digging into the digital bit of the digital industry and space, 'cause there's quite a lot going on. You'll see a bit in the box on the left-hand side. The initial list is what's covered in what's known as the main work program. I cover that. Smart networks and connectivity, as Alex touched upon earlier, is within that lot. There are also separate calls on the 6G smart networks and services because that's where it's funded out of, although it's put together separately. And I also look after chips, JU stuff, which is more about electronic systems, components, semiconductors. Basically, it's a long-winded way of saying you may well look at the 6G smart networks and services topics, but depending on what you're developing or what your end use case is, there may be opportunities elsewhere, and myself and other colleagues in the UK can help you figure out where might be appropriate. Next slide. Right, as mentioned, it's collaborative R&D. The smallest size of consortia bidding in needs to be at least 3 independent legal entities, each established in a different EU member state or associated country. And the UK is an associated country. At least one of those 3 needs to be in an EU member state. In practice, consortia sizes are usually about 5 plus, but it scales according to what's required, depending on the topic and the budget and so on. It's usually a mix of companies, universities, research and technology organizations. Again, the balance and where they come from and their specialism varies according to what the topic requires when you're bidding in. Funding rates down the bottom, some of you may well know them. The main things to watch out for are whether it's an RIA or an IA. The RIA, Research and Innovation Actions, they're lower TRL. Most of the SNS calls are RIAs, so if you're a company, it's a 90% of your direct cost and a 25% contribution towards overhead. If you're a non-profit, it's the 100% direct and 25% overhead. There's only one innovation action, and that's, I think, it's a Stream D topic, which I'll come on to shortly, and Alex touched on that. Next slide, please. Right, couple of quick slides round about the area. Again, Alex has talked about most of this, so it's really just a few specific links to some areas. The bit to remember really is UK organisations are eligible to apply to the calls. You do get funding. You're treated pretty much the same as any EU member state. So it's all pretty straightforward from that point of view. The mention of the 6G Industry Association, that's the membership body. It's actually quite a good mix of universities, RTOs and companies from all across EU and quite a few UK as well. They put together the roadmaps that underpin calls, but it's also a very good place for networking as well. If you're involved in the industry association, you've kind of fed into what ends up being the calls eventually, and you've got a good idea what's coming up, and you're talking to people who may have an interest in bidding in as well. Next slide. Right. This is just a quick summary of the topics themselves. The link at the bottom will take you to a PDF with the topics. Many of you may well have this anyway, but it's just to show it visually, essentially. A lot of the topics are the Stream B ones, and you can see the TRL range in them and the typical budget and whether you're funding one project or several projects. And so the link at the bottom contains the full text around each of those. Next slide. Thanks. Right. The reason for putting this one up Officially, this is one of the main repositories for European Commission information on topics. If you just search for EU funding and tenders portal, you'll get to basically this. If you want to find the SNS topics, you just stick that in as a keyword, top left, make sure it's filtered on Horizon Europe and so on, and you'll get this. The hyperlinks will take you into each individual topic, any specific related documents round about it as well. If you want to search for any other technical or sector areas of interest, just vary the keyword and do a search, and you may find other opportunities. There's a lot of information here. It's sometimes a bit complex to find it. If you've got queries about it, please get in touch with me. Next slide. Again, Alex touched on this. I'll go through this very quickly. I think it was probably in relation to the 3C networks at the top. Kind of grew out of what used to be cloud edge IoT, but with a lot more connectivity. But the Commission term is connected collaborative computing networks, or sometimes they refer as telco cloud. There are topics in 2025 in digital. There will be topics in 2026. That's now effectively public, and if anybody's interested, get in touch. I'll show you where. There's also activity around about virtual worlds as well. Next slide. Thanks. Quick list of links. The first few are pretty self-explanatory. Cordis, that's the EU's repository of funded projects, details on it, who's in them, how much money they got, and a link as to how to contact them. It's searchable. There's a lot of useful information there. Long-winded way of saying it's about contacts and contacts of contacts and building up the networking. There isn't a single way of doing it. Next slide. And I'll finish off with this one. The screenshot on the left is what happens when you filter a little bit within the Cordis system. The projects there are the ones that there are UK partners in. If you click into all of those, you can see everybody who's in it, and there's a link there to allow you to link with them. The one over on the right is one you'll find in SNS, not filtered by country. And that's it from me. Thank you.
Thanks very much, Craig. And thanks for the support that you had over time with proposals in as an NCP. Now we move to Professor Dimitra Simeonidou, Director of the Smart Internet Lab at the University of Bristol, to give an overview of the UK advanced connectivity strength and capabilities. Dimitra?
Thank you, Kostas, and thank you everybody for bringing the background of these calls forward. What I would like to do in the next 10 minutes is really presenting the UK ecosystem. I have to say that we have a highly connected ecosystem in advanced connectivity R&D topics, and that's what I would like to present. And of course, we are very keen to see how we can actually bring this ecosystem within the European activity, and specifically in the SNS calls. So if we go to the next slide, just to say that probably you have seen this slide many times, but a couple of years ago, we actually had launched the UK Wireless Infrastructure Strategy, which actually brought a number of R&D interventions in the UK that we continue right now and we are taking forward. And these interventions, and you can see that was up to 100 million, and I believe that now we have reached this 100 million investment and probably exceeded it. It looked at two different parts of our ecosystem. The one was our universities, and it's well recognized that UK universities actually, they engage in excellent collaborative research, both within the UK and outside, and both within academia and industry. And the second part of the intervention was really looking at companies, large and small, that actually, mostly small, that they are actually carrying out research and innovation in the future connectivity space. If we go to the next slide, I would like to talk about the academic interventions. So 2 years ago, we had actually funding of 4 of what we call future communication hubs, of which 3 are research hubs, specifically focusing on key topics, and the third one is an infrastructure intervention. So the first one is a hub on network of networks, which is actually led by Harald Haas in Cambridge, and that is called TITAN. And this hub, TITAN, is looking really at the whole system, all the technologies that they are actually there to deliver end-to-end systems. So looking across terrestrial, non-terrestrial, wireless, optical wireless, quantum, and actually how these technologies that we are innovating in the UK could actually deliver system blueprints and solutions for future networks. The second one is called HASC, which stands for Hub for All Spectrum Connectivity, led by Oxford. And in this one, really, we are looking at topics of spectrum innovation, and the spectrum, that's why this is all spectrum, is looking from low radio frequencies to terahertz to optical wireless. And we're looking what is the opportunity as we are expanding our spectrum resource across bands that they are not currently used in our mainstream communication system. And the third one is recognizing that actually future networks are not only connectivity. Cloud is a very important part of this, and actually cloud to edge continuum as well. So that computational continuum, and with the rise of AI and machine learning for networks and beyond, we understand how computation resource together actually with connectivity resource is very important. So those are the 3 interventions that really bring together at the moment about 90% of the UK academic capacity that they're collaborating and funded across these 3 hubs. Then we realize that actually when you are looking at research, especially low TRL research, and especially research on networks, then and when actually the ambition is to see how UK-born technologies or not UK-born technologies would fit in future telecom systems, then actually being able to trial these technologies and solutions in an infrastructure that looks like a real-life network is very, very important. So we have funded JOINER, which stands for Joint Open Infrastructure for Network Research, which I have the privilege to lead. And this is really a national network now extending international as well, that underpins our telecom research in the UK. So if we go to the next slide, all these hubs are coming together in a very connected structure. So we call them the Federated Telecoms Hub structure, where we are bringing TITAN, HASC, CEDAR, and JOINER. And the whole idea is that, okay, we are having collaboration and knowledge exchange across these different topics. We are actually hosting experimentation in JOINER across all the areas of R&D that we are supporting in the hubs, but also across ourselves, we are looking the opportunity of research translation, commercialization, collectively looking at IP creation, contribution to standards, and of course, as we are all academics, designing actually ways of best practice for skills and training provisioning across academia and industry, so we can grow this next generation of innovators in the advanced connectivity space. Next slide, please. So what I would like to talk now very quickly is just to, if you like, focus on infrastructure interventions that UK government funding has actually brought the next few years to support telecom research. And the first one I mentioned, JOINER. Of course, this is very close to my heart, but what JOINER is doing is actually providing a national infrastructure for research and experimentation that brings together connectivity, cloud, platforms, and APIs. I'm not going to go to more details. As you see here, within actually Joiner, we are interfacing also with a national dark fiber facility that links and with that national infrastructure, and give us for the first time an opportunity to actually bring and experiment across, for example, classical and quantum networks as we are going forward, and we are posing questions where and when actually quantum technologies they are going to be accommodated in the medium term as we are designing our future networks. So Joiner, please look at that. We are having a number of events that are happening in the future, and actually next week Joiner is launching capability to collaborate with industry, not only with academia. So this is our national connectivity, advanced connectivity capability for supporting R&D. But Joiner is not the only platform, experimental platform that has been funded. The next one is the National Dark Fiber Facility that goes for much longer than Joiner, and this is 1,300 kilometers of dark optical fiber in the UK. You can see the locations there, connected into Joiner, but also on its own it supports physical layer, advanced optical research, but also quantum communication and networking experiments. If we go to the next one, I would like quickly to introduce Sonic. This is another experimentation platform which actually is there to support higher TRL, medium TRL research, so engage actually with SMEs and companies that they're bringing open networking products into the market, starting with Open RAN. So this lab up to now has been serving as an interoperability lab for Open RAN products, bringing the community together actually to look at the advancements and any interoperability issues between different vendors. For instance, some vendors bringing a DU, a CU, others bringing a RIC, and how we can bring this together to actually have multi-vendor open RAN environments. If we go to the next slide, please, and I know that I have only a couple of minutes. So if we are looking at Sonic Labs, they are led by the Digital Catapult and Ofcom, and very industry, they have an indoor test network where interoperability trials are going on, but also a very interesting outdoors Open RAN capability for actually in real world environments testing Open RAN solutions, and now is moving beyond Open RAN solutions to a wider open networking solutions. And Sonic Labs are also one of the hubs of Joiner. So Joiner as a national infrastructure is actually reaching and integrating with the Sonic Labs. And I have one more slide, because of course we are big advocates of large scale, of AI, of new architectures, of new products and interoperability and open networks. And when you are opening up all this in order to place products into operators' networks, then security, anomaly detection is very important. And the UK government has actually funded what is called the UK Telecom Labs, where actually they have a very sharp focus on that telecom security, high TRLs. It is the place where products, as they're moving from low to high TRL, so products from established vendors, they are actually being tested in terms of their security before they go to our operators' networks. So a very complete, a very connected, there are so many other things that are happening. This is not the whole ecosystem, but that gives you an idea how we connect together and work with each other across academia, across industry, and on top of these platforms that actually together they give a unique capability, I believe, in the UK. Thank you very much.
Thank you, Dimitra, and thank you for this overview of you, as you said, from low TRL and the academic blue sky research to products and services that an operator would want to test in the network. So a breadth of opportunities here. So we are now going to find we have pitching across 7 potential partners for your new proposals, and trying to showcase capabilities from industry and academia. The first on is Perikles Petropoulos from University of Southampton. Please stick to the 5 minutes, everyone. Thank you.
Thanks very much for the introduction. So I'm Perikles Petropoulos. I represent the Optoelectronics Research Center at the University of Southampton. Next slide, please. So we are the Optoelectronics Research Center. We are the largest photonics group in the UK. We have around 350 research staff and PhD students in our center. We have traditionally been very much involved in European projects. So with this activity today, we are trying to strengthen or re-establish our links with European partners, which have somewhat been compromised during the Brexit and the association period that followed. We have quite a long history in photonics. Our research is underpinned by very strong cleanroom capabilities. These include capabilities for fabricating our own fibers and also fabricating silicon photonic and other integrated photonic integrated components. We are very experienced in generating and protecting intellectual property. Quite often at our university, it is said that our center generates about half the university's IP. And we have strong industrial and university links throughout the world, actually. Next slide, please. Our communication activities are centered in the in the telecommunication systems lab. This is a state-of-the-art communications laboratory within which we carry out research on optical transmission, new fibers, new waveguides. We are very active in applications in optical signal processing using either linear or nonlinear optical effects. As I've said previously, and as is common with many of the activities at the ORC, our research is underpinned by our fabrication capabilities. So in the lab, we are able to experiment at a very early stage with new photonic components. We have on-chip capabilities for testing new integrated components, and of course we can connect in a custom, in a tailored fashion to novel fibers and novel waveguides. We are part of many of the activities that Dimitra was just mentioning that take place at the national scale in the UK. We are part of the HASC and TITAN communication hubs, and we are a node in the National Dark Fiber Facility and the joiner infrastructure as well. The next slide, please. So this is another slide about our lab capabilities. We have set up our communications lab as an openly accessible facility to allow researchers even from outside our university to access it and experiment on it. The lab has very fast capabilities for generating and detecting signals. We can generate and detect signals at speeds up to 100 gigahertz analog bandwidths and 256 gigasample per second sampling rates. And we have these electronic capabilities complemented with optical capabilities across the frequency spectrum. Next slide, please. As I've mentioned before, we are a node in the NDFF facility, in the National Dark Fiber Facility, and through that to the joiner experimental facility as well. And on the next slide, next slide, please. Yes. So on this slide, I have just a few words about a few more words about what we're doing in research. So I've mentioned that we carry out research on new optical fibers. So we have carried out a lot of work on hollow core fibers. I think we are recognized internationally for our work on this. So we develop and fabricate these fibers, but we are also very interested in understanding how much we can do with these new fiber technologies. Of course, they can be designed to operate anywhere in the spectrum. So this capability is complemented with a parallel capability in optical fiber amplifiers. We have several different technologies that cover different parts of the spectrum, and we implement communication systems across these different regions of the spectrum. And one final slide, and I'm closing. So this fiber capability, as I've said before, is complemented with strong interests in integrated photonics. This slide shows an example of some type of the work that we are doing, where we are processing in a nonlinear fashion optical signals and combine them with microresonator-based filters for complex functions in optical networks. We also have interests in optical computing and fast optical modulators. And that's it from me. I see Costas there. So
Thank you very much, Pericles. We move to Costa Churkas from Real Wireless.
Hi everyone, very good day to everyone. Thank you, Kostas, for the introduction. So my name is Costa Churkas. I work for Real Wireless. My email's on the first and the final slides, so you can reach back out to me if you have any questions. I will also be at the Bristol event that Dimitra spoke about on the 24th of June. If you want to follow up on any of this, if we can go to the next slide, please. Quick introduction on who Real Wireless are. We are basically a niche boutique consulting company spanning the complete value chain, if you like, of the sort of wireless and telecom ecosystem. We pride ourselves in helping to bridge the gap between the sort of demand side and supply side of wireless telecom solutions. So the wireless industry, the vendors, the operators, and the wireless users, or what DCIP increasingly call the adoption side. So transportation, government users, retail, and do a lot of work with stadiums. So we like to speak about telecoms in real terms, and we try to create a reality-focused agenda. At the same time, we are very interested in R&D. Next slide, please. And we are technology-centered as an organization. So we do things in terms of the Horizon partnership scope. We are working with innovators. Oh, too fast. We are working with innovators in technology. So we do Horizon scanning, spectrum, consultancy and advisory, network architecture, and performance analysis of networks. We do have a very deep simulation and modeling expertise around wireless systems. So we've used that on occasion. In R&D projects, but also in commercial projects. We also do a lot of economic blueprinting, business cases, policy and regulation advice, and techno-economic studies, which tends to benefit mostly the higher medium TRL projects in building out a narrative towards adoption and monetization. And we also look across the deployment and life cycle of networks. So we've done a lot of work with neutral hosting and spectrum sharing. We've been fortunate enough to be able to utilize the Sonic outdoor testbed on one of the spectrum projects that we've done, spectrum research projects. And we also tend to look at the complete market for product solutions and creating roadmaps. So the next slide, please. So we are, as technology centered, we are affiliated with a number of different organizations, sitting on the board of some of those. My colleague Julie Bradford is in, for example, on the board of Cambridge Wireless. We're also a member of the 6G SNSIA, which is the organization that Alex just described earlier. Next slide. We are looking across the different levels of impact, the different dimensions of impact, environmental, economic, and societal, when we build these impact assessment models for various different technologies. So we have done a number of projects with the European Horizon program over the last 9 years. We've been very fortunate to be part of that project, supporting the various different consortia. Here's some examples of the 5 different projects that we've been engaged in the last few years. Sustain 6G is the latest one, which is started a few months ago. TrialsNet in the middle is coming to a close soon. And then the other 3 have been successful in the recent past. We're looking at the development of KPI and key performance indicator frameworks, sustainability, impact assessment. We've also held roles as innovation managers and exploitation managers, a number of different projects, consortium projects. We're looking at various different industry sectors, so airports, healthcare, industry. We've been able to ascertain different business cases for all of these different sectors in the past projects. And we are also looking at things like innovation management when that opportunity arises. The next slide, please. So this is a reasonably complex slide that highlights how we build strategic focus, looking at the links between technology, value, both social and economic value, and our modeling and our assessment is helping our partners and our consortia deliver the value propositions behind the technology. As we are very centered on the technology area, we are able to apply our deep dive understanding of the technology to apply that to business cases. And the next slide, please. So this is the final slide, which basically gives a little bit more detail on each of the 5 different Horizon projects that we've already engaged in. I've already highlighted most of the areas that we focus on. Techno-economic assessment, industrial and business use cases are key things that people use us for. We also have in the past done trial and pilot impact assessment independently of the actual vendors or operators who are delivering those. So we've been able to apply common trial assessment methodologies to demonstrate impact and success. But we've also been able to develop common exploitation management and impact assessment frameworks. And we've done also horizon scanning of technologies at the early stage, and also independent due diligence on technical use cases and technical propositions. So we tend to operate across the TRL spectrum, from fairly early TRL, where we act as a technology reviewer, advisor, and all the way to the kind of fairly advanced techno-economic impact assessment. And we're able to engage with consortia from SMEs to large vendors to sort of bring all that together into a coherent whole.
Thank you, Costa.
That's me done. Yeah, thank you.
Thank you. And we move to Nicola Scheidegger from Parallel Wireless.
Hi, everyone. So my name is Nicolas Scheidegger. I'm head of UK R&D for Parallel Wireless. If we go to the next slide. Thank you. So Parallel Wireless is an American company. We're a RAN equipment vendor, primarily focused at the macro cellular market. Apart from the core network, which we don't have in our product portfolio, our product portfolio includes pretty much every element of the RAN, including CU and DU, also RU, and the management components like SMO and RIC. We have this coverage for all the radio access technologies, so 2G, 4G, and 5G, and obviously we're also looking at 6G now. As a company, we have 800 employees worldwide. We're very highly innovation focused and innovation driven. And we apply this innovation to essentially produce technology and products that are differentiated through their energy efficiency and through their ability to improve the cost effectiveness of the network, so reducing the TCO. In the UK, we've had offices in the UK almost since the start of the company, 2013. We've got two main centers in the UK, in Bristol and Harrogate, with a total of over 60 engineers. We have a broad array of capability in the UK office, meaning that we are able to pretty much take care of full projects, but we have particular expertise in a number of areas, such as systems architecture, L1, L2, L3 development, with a strong focus on strong capability and understanding of CPU architecture and how to write high performance software. Systems integration, so we have a number of labs. And then in our Harrogate office, we have a very strong RF engineering team as well. And again, all of these resources are applied towards developing technology and products towards greater energy efficiency in the RAN. Then we also have a network deployment team. If we go to the next slide, please. So this slide summarizes the kind of collaborative R&D experience we've had out of the UK offices in the last 5 years. We've had the pleasure of collaborating with a number of people on the call today. And as you can see in that little map, which represents, if you like, a map of the RAN or the RAN components, we've done collaborative R&D pretty much in every area of the RAN. I'll go very quickly. We've had some research or collaborative research into elements of the RIC. We've done it about timing solutions. We've had a fairly heavily publicized collaboration and research on trying to decouple the CU and DU software workloads from the underlying silicon, trying to accelerate the adoption of new and novel and innovative silicon into the RAN. And then more recently, we've had also a project looking at RF front end and radio architecture. These projects have been a mixture of funding through UKRI, through DCMS and DSIT, and also European projects such as SNS Gold. These projects have really helped us to accelerate the innovation in our product, but a very important thing for us is that these collaborations have also helped us reinforce our partnerships or create new ones. And this is something that is really very important for us, that we collaborate with people and create meaningful and long-lasting partnerships, like the one we have with the University of Bristol. We have a lot of our equipment in the University of Bristol Smart Internet Lab. We have some of our products deployed through the DCIT-funded 5G UK infrastructure around Bristol Harbour side, and all these things are very important for us. And if we go to my third and final slide, so we are looking for further R&D collaboration. We are very open to talk to people interested in collaborating with us. Key areas of focus for us, so I mentioned anything to do with energy efficiency, which can be in the baseband or in the RF, so looking at maybe doing things with RISC-V CPUs or GPUs or machine learning based systems, anything to do with RF front-end innovation, improving energy efficiency. And then in CUDU, timing solutions, algorithms, new DApps, 5G features, utilization of digital twins. You can read the slides. And also, although we are focused primarily at macrocellular, any verticals such as NTN and public safety. I will not be at the joiner event next week, but my colleague John Redding will be there, so feel free to approach him. And thank you very much.
Thank you very much, Nicholas. Now we move to Bo Olofsson from Nokia Bell Labs.
Thank you. Next slide. I'm Bo Olofsson. I lead the Bell Labs office or lab in Cambridge, UK. And I just want to first make clear, we are part of Nokia. I don't think I have to explain what Nokia is today on this call. I assume you all know that we don't make mobile phones anymore. We do all kinds of network technology from wireless to fixed to optical and everything. And being part of Nokia is, of course, a great strength that we can sort of collaborate with different product teams and understand markets and understand sort of where things are going in the real world. But of course, it also means that we have to sometimes adhere to our corporate standards in terms of IP treatment, in terms of disclosure. We are a public traded company and all of that. So some good things, some not so good things, but overall, it's a great strength we think we have. Next slide. But having said that, we are Bell Labs. We are an industrial research organization that is sort of sits outside the current product organization with roadmap priorities and roadmap pressures and things. So we are sort of a research organization that can take some different bets that sort of, looking at more long-term research and also do some sort of hairy stuff that sort of a product-oriented R&D organization maybe can't do. We also have a great history. Next slide. We're actually celebrating our 100 years anniversary this year, and we've done that, and we look back at what we have achieved and what we have done. There's of course a long history of a lot of technologies, both in hardware, transistor, in theory, information theory, in software, Unix, C++, and neural networks that we have achieved. So we span across the whole of Bell Labs a range of different sort of areas of research, and we can tap into that and sometimes collaborate deeply with them, sometimes just get a view and an understanding of where it's going, and that we also see as a very strong thing. We're also global. UK is actually one of the youngest Bell Lab sites. We've been in Cambridge for 11 years. So there are, of course, sort of things that we do and we don't do. Next slide. On a full level, Bell Labs, we try to sort of talk about, we have sort of four areas or pillars of our research. And of course, network fundamentals is still sort of really the core of what Bell Labs is doing. But we define networks and communication very widely. But of course, here we have everything wireless, RAN, but we also have optics, we have fiber, we have sort of IP networks, core things, research going on there. But these are also intertwined because automation is also something that is very fundamental in the networks of the future. So automation is another area where we see we are doing a lot of different research how to automate. And of course, a lot of that is to do with how AI will affect not just the running of the network, but the sort of the development of the network, the testing of the network, and the network's use cases. We do still do some fundamental material and also semiconductor research, primarily in France on the semiconductor side. But there's also something that we tap into somewhere sometimes if we need to do some sort of specialized hardware or specialized sort of chip implementations, we can sort of do that within the organization. Of course, everything becomes software in the end, is the saying we, especially in Cambridge use, and I'll come back to why that, but AI and software in all its sort of different sort of iteration and things is of course something that we are very focused on. We did some very fundamental research in the machine learning and backpropagation with John LeCun when he was at Bell Labs back in the late 90s. Of course, he's now the head AI officer at Meta, but we still sort of have him as alumni to sort of tap in to discuss sort of where things are going and things. Next slide. Now, if we look at specifically, okay, this has gone black instead of white, but that's sort of fine. What we have in the UK in our Cambridge lab, we are about 50 researchers. We will have, actually 25 nationalities, which is interesting, and 25% women to sort of make sure we can sort of present a diverse workforce. We are located on the West Campus of the University of Cambridge, which is basically next door to the computer science department, and also next door to the Cavendish lab, the physics department, and also to Harald Haas sort of engineering department. So we're in the middle of many of our academic partners. We have a very deep collaboration with University of Cambridge. We are funding a doctoral center for mobile, wearable, and systems. And of course, we are connected directly through Cambridge or through our other sister labs in Europe into the European research ecosystem too. We have and still are participating in some of the FNRC lab projects, Reason Plus. We are already in the Horizon project. We were lucky enough to get sort of involved on the first year UK Quebec. So we're participating in the 6G leader. Through our standardization group that is based in Cambridge too, which are doing the global RAN standardization work for Nokia. We have a lot of collaboration in the UK spectrum policy and with Ofcom in that. And also then other universities that we collaborate in, for everything from Glasgow to King's College to UCL and Surrey. So we're already in the UK ecosystem in a very, very good way, we feel. If we look sort of just finally what these research groups in Cambridge are doing specifically, our biggest group is what we call pervasive systems, and they are focused as AI at the edge. And when we talk about the edge, we're talking about all the way out in the sensor or device. How do you sort of gather the data? How do you do data cleanup and data pipeline to make sure that it can suit an AI or machine learning implementation that might sit at the edge, might sit in the cloud, central cloud or edge cloud? But there's a lot of things there that still has to be sort of figured out and understood. And of course, the wireless network there is a key component of it. That group is also looking at multimodal sensitive things, but we also have a responsible AI or explainable AI group that looks in different ways how AI needs to be sort of managed from a responsible and explainable way.
Thank you very much, Bo. We're running out of time. Let's move to the next presenter, Jyoti Basim from Viavi. Jyoti.
Welcome. Hi, thank you, Kostas.
Yes, we can hear you now.
Yeah, I'm just trying to work up my camera and mic. Right. Yeah, I think this should be working now. Hi, everyone. My name is Jyoti Basim. I'm presenting solutions. I am personally responsible for development of new technologies and innovation, which does include all of the work that we are doing on 6G. And you will see in our slide that we are doing a lot of work. Let's go to the next slide. Just to introduce Viavi, we are a large global organization, and we provide test equipment, performance equipment, monitoring systems, and optimization systems. Our tools and solutions, products are being used by network equipment manufacturers, universities, research labs all over the world. We are probably the leader in open networks with our test equipment pretty much in all low-tech labs as well. But other than that, we have other divisions which look after the optical security and performance products as well. Let's go to the next slide. Yeah, probably one slide that summarizes which all areas we work on. Of course, we are better known for our test and measurement equipment in wireless, but we do have other divisions as well. Our portfolio consists of starting from RAN to core test solutions, optimization solutions, lab solutions, in-field solutions, which pretty much all the NEMs and MNOs currently use. We also do have security solutions, anti-counterfeiting solutions, and we work a lot with government and aerospace. Let's go to the next slide. But most exciting part for us really is the 6G leadership position that we are in. So we are bringing all of our research and working on new concepts, new technologies, new research topics for 6G. I mean, as you can see, we've been involved not just in the actual test part, but we are quite heavily involved in the research part as well. We have written a lot of academic papers. We've been part of a lot of technical papers as well. We have patents, either they are filed or some of them have actually been granted. So we do a lot of technology research on 6G topics. And then using those research, we do a lot of innovation. I'm glad to see that many of the organizations that we work with are here in the panel, but also there is a whole other set of customers as well. And we work a lot on all of the newest technology topics. I mean, we've got proof of concept test beds, which are currently being used for a whole host of reasons. It's to develop a digital twin using a ray tracing tool, or doing ISAC sensing. We've got other research and all this we are bringing to our customers and working with them on 6G. Of course, we do make sure that we are able to integrate all of these new products into the existing framework of our customers. So we work a lot to make sure that our 6G products are at least backward compatible to whatever we've been doing with 5G and 5G Advanced as well. Along with the research and proof of concepts, we do get involved in a lot of standardization. We have been putting in papers in 3GPP. We, of course, are one of the key players in O-RAN Alliance. We chair one of the working groups over there. So all in all, we are looking at 6G and open networks as being the bedrock of anything new that we're doing. And of course, we are making sure that we've got tools and solutions to help our customers do their research. Going to the next slide, I'll give you a little bit more on what we are doing. So here's our 6G testbed I was mentioning. And if you can see, we are doing a lot of testing over there. That includes how we can use AI in RAN. And I can details on that. But it's not just the research work we're doing. If you see, we have been involved in a lot of 6G projects around the world. Here in the UK as well as in SNS, we've been part of the previous SNS JU projects. So we are actually putting all of our research to good use and working with some of our partners over here. I'll just be quick with my next slides, few slides. If for more information, you can actually visit our website where we have a 6G forward page, which will actually give you all of these, not just what we are doing, but also there are videos as to how we've been going around doing the testing. So it's a proof of what we've been doing and how we've been testing these new technologies that gives our customers the confidence that we can work with them. And going to my final slide. So there are a lot of topics of interest in 6G for us, and we are working on almost all of them, either with research institutes or our partners in the industry, and of course within the university with universities as well. I bunched them together so that it's convenient to see which of the topics are in which of the SNSJU work streams. But of course, interest is in working on any of the newer 6G topics because we've got the knowledge and the tools to do it.
Thank you very much,
Thank you.
Joydeep. Thank you. Then we move to Zilong Liu from University of Essex.
Hello. Thank you so much for having me. Can you please move to the next slide? My name is Zilong. I'm a senior lecturer and also the 6G Lab director. So I'm going to give you a very brief introduction to the 6G research carried out at University of Essex. So before that, I would like to introduce our communication networking group. This group is currently led by Professor Leila Musavan, and we have 22 academics, including 5 female, and so our current research covers actually on all the communication layer from the physical layer to the application layer. And our vision is to collecting a sustainable future. Next, please. Now, from this communication group, we have a long list of big names. So here I just want to mention a few of them. One of them is Professor Dimitra, who used to be in Essex, and so she's here today. I actually met her in UKTIN event last year in London. So we still maintain a very strong collaboration. Besides, we have Professor Brand and Professor King, who are very senior professor and who have made tremendous contribution to the telecommunications system design. And we also have Mr. Honing Zhao, who used to be the Secretary General of the ITU for 2 terms. Next, please. So for our 6G lab, we are currently focused on the physical layer, especially the air interface design for the 6G. So from the transmitter point of view, we are looking to some advanced communication radar signal design, including sequences, waveform, color books, and the channel codes. In particular, for the 5G and the 6G standards, we need to design many types of preamble sequences, and we also need to have some very advanced multi-carrier waveforms. We are very experienced in that. In terms of the multiple access techniques, in the past few years, have looked into codomain norma, especially the sparse code multiple access. And so based on that, and we have also doing some research on the splitting multiple access. From the receiver point of view, we are very much interested to design some very efficient and reliable, as well as the low complexity receiver processing. And we very much wish to translate our algorithm to influence the industry as much as possible. So we have been carrying out the proof of concept hardware prototyping in our lab. Next, please. So besides this four research, we have been looking into the vehicular communication, sensing, and localization. So we believe that this is a very important direction for enabling of the future collected autonomous vehicle. And we are very much interested in the mission critical communication, also known as ultra reliable low latency communication. Besides, we are looking to the non-terrestrial network. We currently focus on the integration of TN and NTN, as well as some advanced multi-carrier waveform, which can be used for highly dynamic environments. Besides, we are looking to the integration of FSCO and RF. And of course, we are also looking into the machine learning for communication signal processing. We aim to design some AI native physical layer and higher layer. Next, please. In terms of our research funding, we are at one of the core team of the EPSoC communication hub Titan, which includes about 20 partner led by Professor Harold House in Cambridge. Next, please. And in terms of the EPSoC project, basically in the UK, the EPSoC project are the most prestigious research ground. So we have a full ongoing project, working with Southampton, UCL, and Loughborough. Next, please. Besides, we have a number of ongoing international collaboration project with EU, Singapore, China, India, Taiwan. Next, please. Thank you. Yeah, so we look forward to engaging with ORU, especially the partner from the EU for the 6G SNS. Thank you.
Thank you very much, Zhelong. And last but not least, Lei Zhang from University of Glasgow for this session.
Thank you very much, Costas. Hello, everybody. I'm a professor in School of Engineering, University of Glasgow. I will present the Glasgow strengths in the future telecoms on behalf of the team, including Mohammed Imran, who is unfortunately not able to join us today. Next page, please. Thank you. So we have the communication sensing and imaging hub led by Mohammed Imran. Here you can see the research group is quite large. We have more than 40 academic staff and more than 150 PhD students. That happens in all in the last 7-8 years. Actually, we actually go from zero to this scale. We have been involved into more than 40 million of projects. This is outdated. I believe we have much more nowadays. You can see from this picture, our research cover from very fundamental device level to algorithm like physical layer, make layer, and network layer algorithms. And also we focus on data and connectivity and also intelligent networks. I'm going to show you in the next slides. Next, please. Can you please? Yes, please. So can you? Yeah. Thank you very much. So we have very wide collaborations. You can see, including the first tier vendor and telecom operators, Ericsson, Nokia, BT, Vodafone. And also we work together with many universities in the UK and over the world. And also we work with the government and also the Scottish government. You can see we are one of the founders of the Scottish 5G Centre. We have our test bed actually is open to everybody to use and to demonstrate and also to verify algorithms and the concepts. Next page, please. So in the next few slides, I'm going to actually present on behalf of our colleagues. So the slides are collected from them to actually show you our facilities, our projects we have done, and our ideas as well. So the first one is Professor Chung Lee, our colleague working on the device level. So he is one actually focusing on the microwave and terahertz electronics. And we have one of the first 6G test facilities actually in Glasgow University can test about 220 gigahertz frequency. Actually, that is very good for the terahertz communication in the future for 6G. Next page, please. Thank you. Yeah, next, please. Thank you. So this is actually led by Professor Dimitris in Glasgow University in Computing Science on the resilient networks. So his group is working on the network programming, adaptive measurement-based resource provisioning, and also he's leading a group on cybersecurity and the digital resilience for critical infrastructures and connected IoT networks. He has lots of experience on Horizon 2020 and the European projects, leading two labs, NetLab and Cyber Defense Lab in Glasgow University. You can see in the right-hand side, we have the a very wide range of equipments, facilities to test the network performance. Next page, please. So this page is actually on the IoT and also the detection as well. So led by Professor Kama Abbasi and Mohammed Imran. So those are actually coming from two big program grants. They are involved. So one of the projects is focusing on the abnormal behavior detection for the elder people. For example, in the right-hand side, you can see by using electromagnetic waves, they can detect the elder people in the room by using the radio signal rather than the video that can actually preserve the privacy. That is one of the key concern of people who are using the technology in the normal life. Next page, please. So this is led by colleague Professor Berlio, working on the AI-driven electronic device. He's actually working on the next generation EDA tool, try to create a toolbox to be used by many people to design the device, especially for communication systems. Actually, you can see in the right-hand side, those are something designed by the AI-driven EDI algorithms. So it's partnership with MathWorks, lots of direct funding from MathWorks and many other companies as well.
Thank you.
Next, please.
Lei, if you can.
Yeah, the last one.
Yeah.
So this is Trustworthy Connect System, actually led by myself, working on the wireless communication networks, how to build trustworthy between the connected systems and the devices, including the battery, including IoT devices, and for autonomous system, autonomous driving, and the blockchain system as well. Thank you very much.
Thanks, Lei. And you have seen just a very small snippet from the capabilities of in the UK. Now we'll have hand over to Savas Majoranidis from University of Bristol and effectively UKTIN to show a tool that has been developed within UKTIN and how you can find more about the UK capabilities and find your potential partner. Savas?
Thank you, Kostas. Let me quickly share my screen for everyone. Okay. Can you all see my screen?
Yes.
Okay, thank you. So, hello everyone. Thanks for having me. My name is Savas Manzouranidis. I work for the University of Bristol, and for the past 2 years now, we have been developing this platform for UKTIN, which basically aims to facilitate users discover research that is currently happening in the UK, and more specifically telecoms related research. So all of the projects and all of the initiatives that we heard before, you should be able to find it on this platform. So it's a self-service web application that users can freely access and use. So initially, once you register for free and you log into the tool, you will see this dashboard. And what this is meant to help you with is discover research on specific research areas and research topics. So in order to begin your user journey on this website, you have to search for what you're actually looking for. So in this example, I'm showcasing the results for 6G. So what I did is type 6G on the bar and then hit search. And after that, within a matter of seconds, um, we have designed some pipelines that fetch research information from multiple data sources. And these mainly include research projects. So the list that you see here in this table is actually formed by 5 different data sources, including Cordis, that was also mentioned before, UKRI's Gateway to Research. We collect data from the UKTIN website, which has a repository of projects, and other similar websites. So it might look like a single cohesive result, but the work done in the background really alleviates the user's need to go into multiple sources and collect the information. It does that automatically for you. So what you see here is they are all research projects. So you can expand a line to read more information about the project description, to preview what other organizations are involved in this project, and also see what the lead organization is and when the duration of that project was. This table is interactive, so it can allow for filtering. It works like Excel columns. So here, for example, you see that I have filtered out all of the past projects because I'm mainly interested in the active research of 6G. So this is why I have applied this filter. But you can also sort your results using the columns again. I have sorted them alphabetically for now. So for this specific webinar, I think it would be really useful to show that there is a feature to group by organization. And what this does is it changes the same data, it changes the grouping of it. So instead of showing it as single projects, it groups it by organization. So if any of you were looking to identify how active a specific organization is in this research topic, you can enable this grouping and go find the organization that you are interested in, and then see how many projects they are included in. Now, apart from that, we also are generating automatically some charts that indicate useful information to the user. For example, here we have a bar chart indicating how much funding was given throughout the years for this specific search that we have done for the 6G projects. So we can see that most of the funding has been given in 2024, and there is some funding that was given for projects that are still running and will run up until 2029, 2030. And the orange line indicates how many projects have started in each year. And of course, this will be changing every year that as we update our data. On the right chart, we see a comparison of the different funders, and this is also useful for someone that wants to understand which funding bodies are mainly interested in this type of research. And again, let me mention that these charts are not static. They change based on your search and based on your filtering on the table that I showed initially. Moreover, we have a map, and on this map, we show where each organization found in the projects is located. As you zoom in, you can expand these clusters, and you can see the specific name of the organization and where they are located. Now, a new feature that we have added here is the option to view more company information, and this uses the company's house APIs from the UK, and it gives a deeper understanding for those who are interested to get a glimpse of what this organization specializes in from the categories here, but also see the specific people that are included and involved in the organization's control. Now, lastly, this wouldn't be an AI application without a large language model. So on this button, you can enable the AI chat. And basically here you can ask it anything as the chat is aware of your results. So here, for the sake of time, I have already done an example question, which was, which organizations are highly involved in this project? So we have all of these 160 projects, but it's not easy for us to understand which organizations are mostly involved and active here. So this is a good example to use the AI chat for. And within a second or two, you get a response back showing you which organizations are mainly involved in the projects. And of course, you can go back and do follow-up questions to it. Basically interact with your data by chatting and not by manually searching. So this is pretty much it in a nutshell. I know I have run out of time, but please feel free to visit the website. It's free to use, so go ahead and play with it. And if you have any questions, don't hesitate to reach out to me, and I would be glad to assist you if you have any questions. Thank you very much.
Thanks, Savas, and thanks everyone for presenting today and for audience staying with us. I see there is one question in the chat around if this opportunity, the smart network and services, is the right one for a smart cities team from Manchester. I think it's a local council. Or should we look at other opportunities? Do we have Craig online who potentially?
Yep, still here.
Yeah.
Probably going to require an offline conversation because it comes down to there are a number of options. I can show you what they are, but it's probably a one-to-one conversation to try and figure out where you best want your chances. I can give you an idea of typical success rates, deadlines, a bit more background information round about them, but ultimately the applicant is the one who decides.
Thanks, Greg.
So fundamentally get in touch with me and I'm fine.
Thank you. And that's why we have our national contact points. So try to utilize them, ask them questions. As Greg said, it's not just this opportunity. There are others based on what you are looking at, different TRL levels, different consortium and timings potentially. Any other question? Please pop it in the Q&A. If not, then I would like again to thank everyone. Just as a closing remark, we heard from the UK government on the purpose and the importance of UK partners and UK organizations to still collaborate in European Horizon projects. We heard from Alex on this specific opportunity from Smart Networks and Services, and Craig on how the national contact points effectively can help you build your consortia and put the proposals in. Also then from Dimitra on specific capabilities, large-scale projects and programs, and then from individual, from industry and academia on specific technologies and specific, say, opportunities and potential partners. And finally, from Sabas, a tool that UKTIN has developed on how you can find more details about the UK ecosystem, what are the opportunities and their strengths that they have been doing research on publicly funded projects at this stage. With that, I would like to close this webinar and thank you again. If you have any question, please send us email and follow up, and thank you again.